What's going on, AP statisticians? Here to just describe how to go from a two-way table in order to a Venn diagram and talking about this idea of being mutually exclusive. So for our situation, the student is interested in the weather conditions and whether the bus they sometimes take is on time or delayed. And so first we want to take a look at, they track the data for 1 year and they list the information in the table below. So we can initially see some information. We can, for example, first find our totals. So we know that, for example, there's 170 days that were sunny, 120 days that were cloudy, 55 days that were rainy, 20 days that were snowy, for a total of 365 days. Meanwhile, there were 8, 23, 35 days that were where the train was delayed, and we've got 330 days where the train was on time. So again, this is talking about how do weather conditions, do they play any impact on whether or not the bus that the student takes is delayed or not. So this is a great chart. Okay, this is a two-way table. It shows us a tremendous amount of information. I want to remind everyone that this data right here, our data right here that's inside our table, we see those as conditional frequencies. And meanwhile, on our edges are totals. That's what we refer to as marginal. Marginal because they're on the edges. There are totals, the margins of our table. So let's take a look at how we're going to translate this from a two-way table into a Venn diagram. And in order to have a Venn diagram, we need to declare two events. So I'm going to let A be snowy, and I'm going to let B be delayed. So we have two events that we've declared. All of a sudden, I'm going to take a look at a Venn diagram. I'm going to have event A, and I'm going to have event B. And the first thing that I want to take a look at is what's going on in my intersection, because that's all the times that we were snowy and delayed. So as I take a look here, I had 12 instances in which both of these things were true. So I can see clearly that there are 12 instances where we are snowy and delayed. Now there's some times that we are not snowy, we're just delayed. So I take a look here, hey, all of these instances, those are times when we were delayed, we just didn't happen to be snowy. And so I got 23 instances of being delayed, but not snowing. Finally, we've got, hey, how many times were we snowy, but we weren't delayed? I can clearly see that that was 8. And this only represents 43 instances. The other, everything else that we haven't talked about, all of these times where we were on time and not snowy. So adding that up, that's 155, 315, 322. That's happening out here. There are 322 times where we're neither snowy nor delayed. The last piece that we wanted to talk about is, hey, do we have a situation where these events are mutually exclusive? And the key here is these 12 individuals, or these 12 times in the year that we were snowy and delayed. And so these events are not mutually exclusive. These can happen at the same time. So they're not mutually exclusive. Looking at a Venn diagram that would be mutually exclusive, let's take a look at the events of sunny and cloudy. Okay, so for example, I have a situation here. Let's increase, let's add a page. Let's let C equal cloudy, and S be sunny. So as I take a look here, again, I got my Venn diagram. I've got my cloudy days, I've got my sunny days, I've got my days that are neither cloudy nor sunny. So let's fill out those ones first. If I'm not cloudy and I'm not sunny, well, then I'm rainy and snowy. So there's 48 days there. So we have 48 days that were snowy or rainy. I had, how many days was it cloudy? Okay, well, we justified 115 days as being cloudy and 167 days. Let me make sure I get that number right. Yep, 167 days as being sunny. But there are no days where it was both. It's either cloudy or it's sunny or it's neither. We can't have both. So since the intersection is empty or equal to 0, sunny and cloudy are mutually exclusive. All right. Hope this helps define that term mutually exclusive. We're going to come back in our next video. We're going to talk about using that general addition rule, which is going to be really important for finding or probabilities or the union of two events.